Hey, my friends. It's good to see you all here today. Welcome back. Oh, good. Yep. The uh, Melinda and I were just discussing a moment ago. We found the discussions that have been happening spontaneously on this forum to be really, really interesting. So, thank you all so much for being here, for participating, for sharing your thoughts and ideas. Again, together as a community, we're establishing what the best practices are in being nature journaling educators, and or just educators. And we're I think it's been a lot of fun. Um, the so for today we don't have a usually we do not have a prescribed topic. We find if there are any issues or questions that are burning with people, and we can riff off of those. If there are none that come to people's minds, then I do have a I'd love to talk about questions, categories of questions, scientific methodology, and what it isn't. Um, and but if there are other questions that are currently, Rebecca, um, let's jump over to you.
Hi, this isn't a question. I want to say I had a couple of aha moments after our discussion last week. Um, the first one, we were talking about, it was based on somebody's question, Joe's question, I think, about what do you do when, if to sort of correct the kids if they're wrong, and how do you, it led to this whole discussion about discourse and how science is, it's like a collaborative process that we're learning alongside the kids, and it's not really about right or wrong, it's more about the process of that um, learning. And maybe somebody else could sum it up a little bit better, but the it so the first thing that it made me realize is that um, I think there's a lot of pressure as naturalist and an educator to be sort of a nature guide, and um, to, you know, like if I'm gonna lead a nature walk for somebody, then like, oh well, they'll want to. What if I don't know the name of everything? Then it's kind of easy to feel like an imposter syndrome, especially myself as a young professional. It's, you know, and I have a degree in, you know, environmental science, but even so, it's easy to feel like, what if I don't really know enough to be able to teach somebody else?
Mhm.
And so I think that realization that we talked about last week is super important for realizing that it's okay, even as an educator, you don't have to know all the answers, and because it's more about what we're teaching them is the process and how we explore things. And the second aha moment that I had is, one thing that I've spent a lot of time thinking about is the intersection of scientific knowledge and traditional ecological knowledge with Indigenous peoples. And there's this, yeah, I did a whole project about it in college. I made this picture book that blended the two. But one of the questions that I really had to grapple with is, what do you do? How do the two forms of knowledge work together? And what do you do when they don't always match up 100%? They both have a lot to learn from each other, but there's this tendency to see scientific knowledge as validating traditional knowledge. It's like, oh, Indigenous peoples believe this, and then science was able to then study it and prove it and validate it, but it wasn't proven, you know, until science looked at it. And the professors that I worked with in college were saying, well, it's not that you need science to validate it, it's that, you know, they're both two ways of knowing, and um, and how do they interact? So I think that the discussion we talked about last week with it with kids is it kind of can apply a lot to this too, to say that they are both valid already on their own, but we can both work together, and it's not about which is better. It's about that process. So I've been talking for a while, so I will let somebody else go now, but I just wanted to bring up those two things that I realized after we talked last time.
Yeah, Rebecca, that's really useful. The way that the framing of ways of knowing um, is, I think, very very useful in this context. In this context, um, let's uh, and 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 it would be really interesting to explore uh, interactions with traditional ecological knowledge. Um, Joe has reminded me that last time we had kind of opened also kind of a very interesting can of worms, and I think you're referring this to, and I think it would be fun just to kind of get into that can and splash around a little bit with all the worms. And I was wondering if we could. I see Joe has raised his hand. Let's jump over to Joe and see if there's something that thoughts that he wanted to share, address, and that might help us kind of get back into where we were when the last conversation ended.
Thanks, Jack. First of all, I felt that you're drawing the distinction between discourse and debate was very apropos. It strikes me that the concept of debate having a winner and a loser, and discourse being something that actually enhances relationships between people, is really an important one. Um, that you summed up really what I was trying to get at. And I inappropriately said something about letting the kid be right even if they're wrong. That really wasn't what it was about. It
Mm-hmm.
was more, how do you resist a power struggle? And I have seen teachers who, when a child or a teenager or anyone actually suggests something that's outside their own knowledge range, and yet they feel the pressure to have some sort of answer because they're a teacher, um, suppress that kind of comment. And I also truly believe that you can suppress a child, particularly in doing that. And then the final follow-on question I had was, some months ago, you brought up the example, as you did the last time, of Amelia saying, well, what, what is your data source on that? Or something like that, when her teacher said something. And I could imagine, particularly your child, who's been trained this way, asking a question like this in all innocence.
Mm-hmm.
And a teacher feeling immediately threatened, like, my data source, you know? Um,
Yeah, I think I was saying, what is the evidence? Yeah, she asked,
okay,
what's the
yeah,
evidence for that? That's right.
yeah. And and that's a really, to me, that's a wonderful question, which invites a whole, a whole investigation into, well, what is the evidence for that? And how do people come up with the evidence for that? And why, why do the majority, pardon me, sorry for these coughs.
No problem.
What is the, why do the majority of people think this way? But who counters that? And, it's just a wonderful thing to do. And it should be non-threatening. And the answer is, a possible answer as a teacher might be, you got me, I read that, it was in a textbook. Um, Certainly somebody must believe that's true. So then how do you get from there to feeling comfortable with a child and saying, but why don't we investigate that together? What I'm mostly concerned about, though, is if a child's point of view is different from the teacher's, how to accept that difference without making, how to say, well, maybe you're right. Maybe you're right. Maybe I am not seeing this. Maybe you're onto something here, right? Maybe I'm actually talking to the next Nobel Prize winner in biology. Do you see what I'm saying? I mean, it's
Yeah,
like,
yeah. You're talking about how can you maintain humility in the face of the great unknown, in our thinking in the middle of of discourse. Once an idea gets stuck in our head and we think we know what's going on, it's very, very, very powerful. And the other little piece of this is, speaking of power, is the power dynamics between teacher and student. And um, if you are, going to have a, a free conversation about rights in the presence of the king, right? And the
mhm.
king holds sway over whether you live or die, if they like you or don't. That's not fair. And similarly, if you're having a conversation in the presence of somebody who holds your grade in your hand, um, there's an uneven power dynamic there. Katya has something to add here.
Yeah, I always have something to add when it comes to education, right?
Please.
First, teachers are human. We learn what we've been taught, and we learn what we've seen modeled. And modeling is like the most amazing thing, because you can say A, but if you're modeling B, we're seeing B. That's what we're learning is B. So we need to be in a place where, firstly, especially in the last 10 years with standardized testing, 15 years, with the increase of standardized testing, teachers are very largely being held with their nose to the grindstone. If your kids don't perform on those tests, you're in trouble. So there becomes a problem. But I came from a family where my mother taught me to ask questions, and so it's what I learned is that you try and set up a dynamic. And also, because I was very invested in my career, I did research in what's effective and what's not. And so, like, even when it comes to discipline, I tried very hard not to be the teacher who punished kids, but I did have a very good discipline going on in my classroom because I made the kids responsible for their own behaviors.
Mm-hmm.
We have very simple rules. Treat others the way you want to be treated. We discussed what it meant, and the kids bought into it because they knew that if I keep doing something that's not productive in the classroom environment, we all lose out because we lose time. We don't have the time for that art project that we were waiting for, or to go out for a game that we wanted to play, because we have to finish our lesson. But as I've mentioned, I encouraged kids to talk, to ask questions, to peer tutor so that they imparted their knowledge on one another. But that's part of a learning cycle. If I came from, excuse me, I came from an educational program where it's like you were the student, you sat, you listened, and you listened and you listened. And it wasn't until maybe my sophomore, junior year of college that I was actually in a class where we were asked for feedback. What a concept. They actually asked us to tell us our thoughts on something. Okay, all the way to college before I was really asked for what I thought.
Mm.
So, okay, now, as I said, my mother taught me to ask questions. But had I not had her back there, I would have been that teacher who said, okay, this is the answer. Done. Next. So you have to remember, the students and the teachers are learning right now. We need better models as teachers and not just as students.
Mm-hmm.
So
That's true, because a lot of us have been trained in, say, how to do science, the model a long time ago was that the person who has memorized the most science stuff, that's the authority. The authority is that book, and you're going to do well on the test if you memorize that book. But if you instead are thinking of science as a process of how do you figure things out, then kind of getting back to not just what is the factoid that you're trying to remember, but what is the strength of the evidence for that particular claim. The next generation science standards are really trying to redirect people towards approaching things that way. And that hasn't been the way that science has been taught in a long time. It has been that, here's stuff I want you to remember, spit it back to me on a test. Now, teachers are being asked to do this very different thing of kind of engaging with what is the strength of the evidence for this claim. And the fundamental idea here is that you're going to accept a claim in proportion to the strength of the evidence for that claim. And so having a claim that is disconnected to the evidence that you're supposed to memorize and then repeat back runs counter to the whole process that that we're trying to kind of get students to embrace. So thinking of science as, not just the information that you've required, or what we now call the disciplinary core ideas, right? In next generation science standards parlance. But how was that information arrived at, and how strong is that? And in this way, we're actually really dealing with some important critical thinking ideas. So anytime we're now doing science, it's not about memorization. It's this big thinking challenge of like, here's this claim. What's the evidence for that? So you're, instead of having things being right or wrong, this is trying to put everything on a slider. And new data and information will move a claim on that slider towards greater confidence or less confidence, not towards right and wrong, true and false, but towards greater confidence in this or less confidence in it. Or another way of thinking about that is how useful is this, how explanatory is this concept or this idea. And that's different than things being right or wrong. When I was taking science a long time ago, I thought of that science was the kind of this endeavor to kind of determine truth. What was truth? And that's actually not the in this truth thing. Is this, what are you going to, how are you going to prove something? But when you kind of tighten the screws a little bit on how scientists go about figuring things out, it's not about proving things. It is not about this idea of truth. Here's truth. We don't make the claim to have figured out truth. We can get ourselves progressively closer to it, but we don't have the rule book. We don't have the manual of everything that's going on here on the earth. So we're trying to figure out the rules of this system by looking at the behavior of this system. And in doing that, because you don't have an objective set of rules, you cannot do a proof. So if somebody says scientists have proved this, that just means that person doesn't really understand the endeavor of science. scientists have found a lot of supporting evidence for this idea, and this idea is extremely predictive and really, really useful. That's a good way of thinking about it. But the whole idea of proof and right or wrong, there always have to be error bars around whatever explanation you have. And that also gives us wiggle room in this idea of that, could I be wrong? Well, yes, I could. Yes, I could be wrong. That's why we again kind of go back to like, oh, that's interesting. What's the evidence for that? So this critical question of, that's interesting, what's the evidence for that, is now sort of becoming the foundation of how we approach in science gaining more knowledge. And so for part of this, there's going to be lots of stuff that comes up that you don't know the answer to. You're a naturalist, and it could be just something as simple as like, what's this plant? Or what's the gestation period of a platypus? Gee, I don't know how long it takes until they lay their eggs, and how long those eggs sit around. That's an interesting question. So there'll be lots of stuff that you don't know, and that's fine. But even on the things where we think we know, like let's say that it takes X amount of time for the platypus to lay its eggs after it mates. Still that's based on some specific observations. The more that we can get to the evidence for any claim, it makes all of this a much more accessible discussion. I haven't been following the chat, so and this ties into what Rebecca was saying with the ways of knowing. So science, when it's done right, is a way of knowing that is assessing the strength of evidence for particular claims, and the evidence that we use is either stuff that we can directly observe or infer. And so that's a very, very useful way of knowing things. There are other and when there are other ways of knowing, and it is different than science. And when you are in science class, you're using that scientific approach to looking at explanations for things. But there are other places where you can use other frameworks. There are other ways of knowing things. For instance, some people, a way of knowing things is because you're not looking at the evidence for something, but you're looking at the strength of the authority that information came from. So that could be, it says here in this book that this is the way things are. And depending on how much, faith you have in that book, that then like, oh, then that's another way of knowing things. But it's based on the assumption that book is correct. Or that somebody who is an authority figure that you greatly respect says something, and so you go, well, that must be right, because this person who I respect said it. Or that in my social group, this is something that is a thought that is generally held to be believed. And so I'm not going to question that, because going outside of that that's a threat to kind of group stability. And so sometimes we believe something because that's what our community says. Sometimes we believe something because we get it from an authority. Sometimes we believe something, for a bunch of different reasons. But so those are different ways of knowing something, and in our heads, we want to kind of just keep it separate. There's also this over here. There's this thing called science, and that is when you're doing that, you are specifically looking at claims and the strength of the evidence for those claims. And there you're looking at things that you can either observe or infer. And you're going to, and that's where this idea of the slider comes in that category of science. You're going to be moving that slider around depending on the strength of the evidence for that. And that's not the way that people tend to work with a belief. So when we're doing science correctly, the things that were kind of the explanations and the claims, those we want to think of those as different than a belief. A belief can be held independent of evidence. But a scientific claim has to be associated with that evidence. So that, all of those are parts of how our human minds work. Nobody is out there as strictly, Spock on Star Trek using logic and data to come up with their explanation, the way that they kind of operate in the world. We're all kind of a mix of these things, but it is helpful for us when we are doing one of them to be aware that we are doing that thing. So for instance, if I hold a belief and it is not supported by evidence, that's great. But I just want to be clear that this is a belief that I'm holding, and it's not based on evidence. But what people will tend to do is, if you have this belief, and then people say, well, what's the evidence for that? We as human beings will kind of, either make stuff up or cherry pick. That's where we get into cherry picking. Can I find some thoughts, some evidence that kind of seems to support this? If you are kind of starting with trying to prove that something is true, the way your brain works is really different than if you're appropriately doing science. And again, in science, you're not trying to prove that something is true. Generally, you're much more successful in kind of I've got this explanation. Here's the bunch of evidence for it. You actually move the ball down the field by trying to disprove it, right? The more that, if you can do everything you can to try to disprove that, that ends up in science being a much more useful way of kind of interacting with things. If we're trying to, if we start with a proposition and then try to backfill with evidence to support that, there are all sorts of cognitive biases, confirmation bias and cherry picking and all these sorts of things that will come in and bite us in the tail. I see Sharon has raised her hand. I hadn't noticed that earlier. I'm sorry. I didn't see that markup. Sharon, if you're still with us, please share.
Yeah, I just wanted to mention that there are different styles of people acquiring knowledge. Some people want a definitive answer. They need to know what the right answer is. Other people will permit themselves to investigate an idea with you, so I was a lecturer at university with students that in professional programs. And some of the students were the type of learners that they needed to know what the right answer was and were willing to put in hard work to discover answers for themselves and to recognize that in a medical situation that there are going to be factors that come to play, in how you make a decision about an approach to a patient. So just knowing each student's bias in terms of how they like to receive information, and try to guide them to do some deeper thinking if they need to do deep thinking, I think is also something that an educator needs to be ready to do. That's about all I have to say about that.
Yeah, Sharon, I agree with you that, and that the idea of kind of being comfortable with uncertainty,
Yeah, yeah. Mm-hmm.
that takes intestinal fortitude.
Mm-hmm. Mm-hmm.
Um, and that's something that actually a lot of people are struggling with about this new way of looking at science. Instead of science as like, these are the facts, this is, and where you can turn the science into the authority that's going to give you the definitive answer. You're turning science into a process of investigating things, and where even the idea of a slider instead of right wrong, that it's on this little slider about how sure you can be of that diagnosis. A lot of people are uncomfortable with that because we like the security of the black and white thing. So this makes science a much more nuanced area with lots of shades of gray. And many people are uncomfortable with that because, again, we like to know, like, no, it's 42. End of discussion. It's 42.
Ashley's got her hand up.
Oh, great. Ashley, please. Good to.
So I have been doing research on science education as well as working with a lab of other individuals who are doing similar research. And in our discussions that we have with each other, we often raise the question, is the reason why people need to know, or students need to know what the right answer is because, is that how we train students, right? So when you're in a science class or in almost any other class, going up through grade school, that you're sort of taught how to do school, where you have the right answer, you get rewarded for it. And this is kind of reciprocal process that makes us need to have a right answer rather than giving us time to have experiences with the information that we're trying to learn about. I have had a really great experience with one of my professors who challenged us to not only try to understand, but write down what our philosophy of science is. So how we understand how science works, who participates in science, and what we ourselves can do with science. And that this is sort of a way that I have come to understand my science identity, or how I fit within a scientific community or any community in any way. But I really feel like that this is a really good question that we can ask. Are we training our students to do school, or are we training them to do science? Are we giving them opportunities to ask questions? Are we giving them opportunities to explore and have their own ideas? And so I know that this isn't an easy thing, especially because most of us went through school doing the I know how to do school thing, I can get the right answer, I can pass a test, versus here are some objects, find a problem, ask questions about them, and tell me what you learned. And then in this type of scenario, our students are also coming to develop their own science identity. And with that, they're developing an authority in the classroom where they're, like, as you were talking about before, where they're not just accepting things that the instructor is telling them because the instructor is the science authority, but they are given the opportunity to ask their own questions, to go to books and other experts to ask questions and to get information, and so that then they can then become the science authority and share the information that they have. And so, like you were talking about, Jack, that I am a huge supporter of the next generation science standards and how this encourages students to have more authentic science experiments or experiences. I feel like it's really hard to give students like exactly what scientists are doing because of training and new experiences and things like that. But we can give them questions, or we can give them opportunities to ask questions, and we can give them the ability to feel like the ideas that they have are good, and that that's a good thing to do, and that they can develop as a scientist based on what they're thinking about, not just because they passed a test because they had the right answers.
Yes, and what's another thing, just to kind of plug into what you just said, Ashley, is that this idea of the idea is good is independent of whether the claim is right or wrong, right? So you still have a place at the table, and it's not just based on whether that's that's right or wrong, and we are in that idea is still good whether it's right or wrong. But it also, we are then moving there's a bunch of good ideas out there that are wrong, and that's okay. And it doesn't mean that we're just kind of going to do some kind of postmodernist, like, oh, we don't really know, it's all like, loosey goosey, who, no, actually, there are claims that, that we can show that those don't work. And you don't want somebody your doctor basing their treatment of you on those wrong ideas. That's not good, right? But those ideas still have a place at the table in the discourse. And it's through that discourse that we separate the wheat from the chaff. There's one other idea there. There's a thread that you had that really lit my brain up, and I'm now completely I forgot what it was. Tell us a little bit about your personal a change that you have seen as you've been thinking about this, in how you think in your own personal philosophy of science.
Well, I think that my philosophy of science has changed in that science is a community experience. That I think before I had this opportunity, and maybe even as a master's degree student, I sort of felt like I didn't really have a place in science because I wasn't doing what I felt was important research, or research that really affected change or big ideas in other people. Most of my research was just kind of plant communities in the local area, which I found fascinating and I felt was important, but didn't really have an effect on sort of a global science, right? And as I went through this exercise and read some of the readings that we were encouraged to read, that I really started to understand how science is a community activity, and that it takes experts training novices to ask questions and to have a special way of seeing that deals with their profession or their field. And that it not only takes like one person asking a question, but it takes a group of people asking similar questions and throwing around ideas and pulling out different data and making different kinds of observations to really make science as hardy and as rigorous as it can be. And through this, I have understood that my role as an educator or someone doing education research is actually a really important part of science. And maybe I'm not out there doing like mind-blowing science experiments with rare and important animals or trying to affect climate change directly, but the way that I teach students and the way that I'm involved in science through education is maybe even more important than those scientists who out there, because we're training the next generation of scientists, and we're training the next community of scientists where we are training them to work together and ask questions together rather than compete against each other for the right answer.
Mm-hmm. And that right answer thing is also just, it's so pernicious, isn't it? And I, there is a wonderful educator at Lawrence Hall of Science, Kevin Beals, and listening to him interact with students in discussion a few years ago, I had this profound moment where all the hair stood up on the back of my neck. And I realized that I had been thinking that I was, doing this whole kind of open discourse thing, but there was a pattern that I had that I wasn't aware of, and so now I've been fighting against that. And what um, you've probably seen this when the teacher has an idea in their head that's the right answer. Notice the big air quotes in here around the right answer. So I've asked a question to the group, and then what will happen is a student will say, well, maybe it's this, and then in my head I'm thinking like, no, you're wrong, right? And so then I'm going like, oh, that's interesting. What makes you say that? Why do you say that? And then they explain their thinking, and we can kind of go down that route. But see, when somebody says something and it's the right answer, my response was different, and what I would do is I would accept that, like, yes, that's right, okay, and here's some other evidence, but what Kevin was doing is that when the student who they have the wrong answer would say something, they'd say like, oh, that's interesting. What makes you think that? What's the evidence for that? What do you kind of see with that? And when the student would give the right answer, he would go like, oh, that's interesting. What's the evidence for that? Like, what are you seeing? What makes you think that? And so it's actually the same response. This looked like when you were saying, like that there's, what that's doing is giving equal weight and appreciation to those ideas. And what I was doing is that when somebody would give the right answer, it was a conversation stopper. It was a thinker stopper. I would go, okay, everybody accept what Sally just said, right? That's the right answer, right? And they could see from my response and my behavior. And what I was doing is I was just trolling for the right answer to kind of pop out there. And it was devastating to me. But a very, very useful and powerful thing to notice about how I was responding to this, because I've seen that same thing happen in a lot of my education, where the teachers just kind of Bueller, anyone, and then there's an inside joke among some outdoor educators about the idea of photosynthesis, is that there's a bunch of kids who just know that here in this outdoor education science class, if every once in a while you say the word photosynthesis in answer to a question, a bunch of time you're going to get rewarded for having given the right answer. And so kids will just like randomly throw out, they watched a bunch of kids, and a bunch of them would like at random times just sort of go like, photosynthesis, right? So the but again, that's saying this stuff without any real kind of connection to the thoughts and the ideas there. So this was, for me, I'm kind of outing myself. It was a very humbling thing for me to realize that when I would hear what I thought was the right answer, then at that point the discourse would take a totally different direction, and I would try to kind of tie it up in this pretty bow and go like, okay, everybody, this thing that's just been said, that's the one that's right. Like, you got to keep that one, and now let's go kind of explore something else where we're not right. And what you're saying there, Ashley, about their, really kind of giving respect to these ideas, that the ideas, people's ideas and thoughts, they've earned a place at the table, and you need to figure out a way of handling that is respectful.
Earlier in the chat, I had put an inquiry of the group about whether they had ever used citizen-based science inquiry, gathering data for projects that are ongoing. So what Ashley had to say about the about science being a community endeavor really resonated with me, because all over the country or the world, scientists could be asking us to help collect data, and students could see that they have a role in the scientific community in that way. And I just wondered if anyone in the group had used, any of those projects, science, citizen-based science projects as a jumping board for education.
So I can mention just a few things. I teach a flora class, and as part of that class, the students use iNaturalist to make digital plant collections. And iNaturalist is pretty awesome because you can take, if all you have is a photo and a location point, that can still be very, very important scientific data. And so students who know nothing about plant species or have never seen a plant before in their life can still take photos and contribute to scientific data, because there are so many amazing scientists and experts who are sort of joining together as a community and identifying these plants and bouncing back and forth with identifications. And then there are other researchers who take all of this information and they use it as part of their research. And I actually am working with another lab that is herpetology, and they're using the iNaturalist data from all over Idaho in order to understand species occurrences. And that will then inform conservation efforts for these species. And so there's some really great data analysis that they're doing about where things are occurring, and if they are there based on because observations just haven't been made, or because people haven't been there, or they're just not there. But so this data that's being collected is really important for these scientists that I'm associated with, in order to use that information for conservation purposes and to educate like the Park Service and the Forest Service and BLM about how to contribute to this data source, as well as to manage these types of animals. So those are just kind of two examples at a more university level.
There are one of the things that's wonderful about having your students involved in a citizen science project is that people can see that, like, oh, the way we get information is by people really doing stuff, and you can be involved in something that is real, and that's powerful. That's beautiful. Something you have to be intentional about, though, when you're doing a citizen science project, is that in order to make a citizen science project successful, it needs to be really, really kind of clearly laid out, and like what you do and your role in it is really defined. Otherwise, you're just getting crazy data from all of your citizen scientists. And that means that all of the thought that went into designing that experiment has already been done, right? And so you can participate in this thing, but the thinking that went into the setup, which is, asking the question, figuring out how you are going to investigate that, figuring out how you're going to collect that data and analyze that data, that's actually all been done by somebody else. And so you are a tool in the service of that. And that's really useful. And you can learn some science skills, some science process skills in the course of doing that. But you do want to be aware that you're not going to be teaching the thinking that went into setting that up. And that's going to you have to do some sort of backfill with that in order to make it relevant, and then give your students opportunities to be able to be involved in that part of science as well. That's one of the problems with when same thing when the teacher comes into the lab and you've got stuff set up at your station and they say, I want you to put, this much of this in this beaker and this much of this in this beaker and weigh this and then read from the bottom of meniscus and then give me your results. You're teaching people essentially how to be a really good lab technician. And that's different than the experiment, the thinking that went on into like, what if I combine this with this with this? I could then filter that out and then measure that. Oh, and then I figure out what those, that sort of thinking isn't, you don't get to participate in that when it's given to you on a plate. But but also being involved in a real large community endeavor is awesome. But just sort of it's not bad because it's not doing these things. You just have to realize that you're not doing those things when you're doing a citizen science project. And so you're going to want to make sure that you engage with that in a different place, in a different way. Hey, Billy Joe, I was wondering if I could get you to flesh out for us a little bit more some of your thoughts about, you had some thoughts about the asking the questions, and sort of people's sort of what that would mean you were kind of envisioning a community in which.
Yeah, I was just thinking, I've always been a question asker as well, and sometimes to the annoyance of other people. But I always think that there sort of has to be more. And so I was just thinking, like, imagine if we stopped sort of teaching kids. I think, Ashley said it great. Like, I think her quote was, are we training kids to do school? And I thought, oh my gosh, that's exactly what we're doing, right? We're not really giving them the opportunity to sort of think on their own and to be able to come up with all those different things. And imagine if we had a world with kids who were asking those questions and really coming up with their own thoughts and ideas. Like, imagine the transformation of not only science, but I think society in general. And I think you're starting to see that movement more. I think especially for you guys in the States, there's a big movement with the youth. And I think it's really unbelievable to sort of watch it and to see them become so active and passionate about the things that are going on, and being willing to stand up to the people who are the supposedly right people. And I think that, it continues to prove that just because you have the degree and just because you've written the book doesn't mean that you are, like Jack said, doesn't mean that you're always right. I think science is really interesting in that it is fact-based. There are things that we've proven over and over again to be sort of more correct on that sliding scale. But if we just assumed that that was true, we would have stopped doing science forever ago and there would be no advancement. And so I think that that's really where those questions are going to come for, is that advancement. So to me, like, there's never just a definite right answer, because someone's going to ask a question that sparks you to think, maybe what we know to be true isn't true, or maybe there's another part to that. I think that's a really interesting thing. I was with a group of students yesterday. I was introducing nature journaling to them. They were in person class, and I was meeting with them virtually, and introducing the concept and going through the I wonder I notice, so that their teacher could then take them outside. And one of the kids said, "I wonder why my stick is bent." So his stick was curved, and I was like, "That's a great question." And I was like, "Let's come back to that." And I said, what does everybody think? Like, why do we think that his stick is bent? Because I was like, I don't know the right answer. I don't know where it came from on the tree. Like, and like even I think it was Rebecca at the beginning was like, people think I'm an expert all the time because I teach outdoor ed. I'm not an expert. I'm a nerd, a total nature nerd, so I maybe know some stuff, but expert is like not even close to where I am at. So I'm like, I can't answer that question. So let's get some feedback from these like amazing grade ones. So one kid's like, maybe somebody stepped on it. I'm like, ding, that could be right. Another kid said, maybe it's from the snow. Yeah. Another kid said, maybe a bird sat on it. Yes. So I was able to take all their answers and say, guess what? Like on a sliding scale or whatever, all of those answers could be correct. So everybody in the class was validated in that there was a wrong answer. Did it grow like that? Maybe the sun was over there. Maybe it was just a really chubby squirrel. I don't know. But I think that the really exciting part of that is that every question was validated in that, and I just sit there and I just like listen and watch, right? But I have to admit, Jack, that I have found myself in the same as you, trolling for the right answer. And so now that that's come to light for me, I will definitely make sure that that is something that I'm consciously making sure that I'm not doing, because when you said that, I was like, boom, that definitely I have caught myself. So I am trying. I always answer a question generally with a question, because it's I want them to do the learning. I don't want to be regurgitating information that I've gotten before. And so I think that the more we encourage that, just imagine like what can happen. I have two young daughters, and they'll say to me like, well, mom, how's something spelled? And I'm like, I don't know, how's it spelled? So like, let's go through that process together, right? That's how they're going to learn, is through asking questions. And I think that's really important. So that's sort of what I was going with there. I hope that answers your question. And I talk a lot, so sorry.
Yeah, no, I saw part of that pop up on something you wrote in, and I wanted to give you a chance to share that. Thank you so much. Let's jump over to Melinda.
Yeah, so as Billy Joe was talking and getting excited, I was just kind of like waking up my cells in my body, because I was just in this like listening mode, because there's so much great discourse going on here. But something stimulated an idea in me, and it was on the heels of what Ashley was talking about, how iNaturalist and eBird and these apps are just such wonderful tools that we have in our pockets right now, and that have helped people that don't know anything about nature connect with nature in a way they've never been able to do before. But what I've noticed in my students is that there's this tendency, because they don't know very much, or maybe if they did know a little bit, they take a photo and they'll say, oh yeah, this is a Mississippi wild horned sapsucker, and you're in California, right? And they're like, yeah, it's totally what it is. It's totally what it is. Without this knowledge of, I think as educators, we need to take one more step and say, this is a tool. We are nature journaling. That means we're learning how to observe nature, record what we see, and ask questions, right? We don't need an app to tell us, but if we do use an app, sometimes it's really useful. I use it too. But when you get that answer, it is not the right answer, right? Because you have to understand how these applications come to that answer. They have an algorithm that humans have created, and it goes through and examines the photo and connects it to whatever they have in their database, and it narrows it down to the likely answers. And sometimes it'll come up with an answer that's completely wrong. And I've seen this on my app, when I know one plant is in a one plant family and iNaturalist tells me it's something completely different. So I think it's important for us to know, if we're using this as a tool with our students, that to put the caveat in that we still need to observe, right? So if I get this like, oh, it's a Texas longhorn beetle, oh, in my backyard in California, all right, maybe it's invasive, maybe someone brought it. So let me draw it, and let me see, okay, how many little projections does it have on the horn, and what's the measurement, right? So it's such a great tool because sometimes we don't have a field guide that has all the beetles of the world. Like I know my insect book doesn't have all the beetles, or I think you have to have like this gigantic book to get the beetles. But our
An
naturals can help.
inordinate fondness.
Yeah. iNaturalist can help me narrow it down to maybe a family or give me ideas to look at a field guide for some other bugs. And if I can't figure it out, it's okay, right? So that's what I'm teaching my students. We all teach our students. It's okay not to finish your page. It's okay not to know the name of the thing because that's not what's important. What's important is that we've stopped to look and we're learning how to look. We're learning about things like, oh, I didn't know that I should count the little horns on the antenna, or oh, I didn't know I should count how many legs. I don't know how many. Or oh, you mean the shell, it's got different colors or it's got a different shape. So that's what we're teaching, is how to observe. So I struggle myself too as an educator with this. I know that I don't have the answers, all the answers, and I still, it's that little ego in my head. It's like, well, what are you going to say when they ask that question? And I had someone ask, Melinda, how do I? Here's an example. How do I paint these trees with no leaves without getting lost in all the branches because there's so many branches? And my first thought was like, okay, I remember Jack just did a lesson on that. And I said, you can go on, Jack's website and he's got this great video. And then my next thought was, because what I did is I passed the power on, right? Like it's great to guide them to someone who has more expertise in the specific thing they're asking. But I came back to, they're here in a nature journaling class, and I can just tell them what you would do. You don't have to know how to draw trees without leaves, right? And so the next thought that came up was, Melinda, just show her what you would do. And so I asked her what she was looking at, and I said, okay, this is what I would do if I was sitting at my window and I saw these bare trees, blah, 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 and said I'd do a little mini landscape, and then I'd zoom in on this branch that's really interesting, and then I put I notice, I wonder right here. And then she was so relieved. She's like, oh my God, you mean I don't have to draw all that? So I think it's easy for us to forget when a student asks us a question that we need. Not only does it we feel like the student has to have the right answer, but we have to have the right answer. So it's really important, and it's humbling to come to that awareness. And it happens to me almost every time. It's like, okay, I'm not here. I am not the bearer of knowledge, right? I'm a guide, and I'm helping my students see nature and make these observations and use their direct observation to make connections with nature, to start to think critically, to question, right? If an authority says, yeah, it's this thing, but it's like, and you have that inkling to trust that inkling, and to say what Jack is saying. Yeah, well, how did you know that was the Texas longhorn beetle and not the California pine borer beetle? Right? And to say it in a way that isn't like butting heads, but is like, yeah, let's learn more about these beetles by asking these questions. So what we're talking about here is, I'm getting goosebumps because this is exciting, but it is not the way that we have been taught to pass on knowledge. Actually, you know what? We shouldn't even compare ourselves to what we do in the classroom as like a regular classroom teacher, because we're shifting the way that we want people to learn, to be present, right? Not just be this like empty vessel. We're just like taking in tons of facts. So, and I see that in this process, as I'm teaching that, there's still a lot of unlearning that's going on inside me, right, as an educator. And just to be aware that that I'm also learning, and as I am learning about myself and how do I pass it on to others, I'm going to be a more effective teacher as long as I keep learning as well.
Thank you. Thank you, Melinda. Hey, Rebecca, could I put you on the spot again? You've been dropping some number of really kind of interesting thoughts, and I wanted to give you there's be a bunch of people who are watching this who aren't able to see the chat, and if you want to have an opportunity to share some of your thoughts about about this with the group as we begin to wrap up here.
Sure. Was there something particular that you were thinking?
Um, I'm curious to find out. You helped us kind of get started, and I wanted to find out what's on your mind right now.
Well, right now, Ivea just posted in the chat an idea about a lesson plan that you could make up where you come up with, you examine the same question and come up with different ways to examine that question, different paths to the peak of the mountain. And I actually just sketch noted that.
Mm-hmm. Unfortunately, I made a noise and then it jumped off your screen. So I'm going to ask you to hold that up and I'm going to keep my mouth shut.
And so I wrote in the chat, the more ways that different people go up the mountain, the more, and it's not just about here's a question we have and what are some different ways that we could investigate it, and then which is the best way to investigate it. There are the more different ways that we do investigate it, the more different ways that people take to go up the mountain, the more evidence that we have, the more different types of evidence we have, the stronger the argument eventually becomes, and then the more confidence we have to use that evidence when we're making decisions and solving problems, which is kind of back to what you were saying at the very beginning. With that slider, the more useful. It's not about being exactly proven or right, but how useful is this knowledge and how much evidence do we have?
Mm-hmm. Yep.
And I also, another thing I wrote in the chat a little bit ago is that when Billy Joe was saying, like, I'm not an expert, well, even if you are an expert, that doesn't mean you're an expert in everything, because there will always be more that you don't know. So maybe you're an expert in one aspect of ecology, but you don't know as much about another. And especially if a lot of us are naturalists and more generalists, we want to know a little bit about everything in the natural world, there will always be things that we don't know.
I like that, that sort of scientific humility. You know, when done right, science is both a very powerful and a very humble way to face into the unknown. I like the way you frame that. And so, one thought in closing, and then we're going to let everybody scamper off to get their lunches. We're talking about the importance of respecting these different ideas, the importance of, you know, as a scientist, sort of balancing the evidence. It's not about proving this thing; it's about sort of where you think that slider is. And what we're not talking about here is sort of, there was a sort of a school of postmodernist thought that, you know, because of all the unknowns and all this sort of stuff, like, we can't really know anything. We can't really say, you know, because, you know, and so this idea is just as good as this one. I would like to ask you, would you want a physician who felt that way? And the answer is, of course, no. But because in the face of all of this uncertainty, we still can move the ball down the field in figuring stuff out. At the end of the day, we're still not making the claim that I have proved this, that this is truth, right? So truth is for a philosophical discussion. But in science, we get to useful, and we get to the preponderance of the evidence supports. We're not in the truth department. but we can be incredibly useful. We can get a satellite, just passing past one of the Jovian moons, within a gnat's hair of when we of when and where we predicted it would go, because of our understanding of gravitation. It doesn't mean that we now have got gravitation totally nailed down. It's still kind of like, yeah, but we've got our ideas about it are useful. Our theories are useful and they're predictive. We can say, like, if this is true, I'd expect to see this and this and this, and we can look and go, yeah, we did see those things. That's pretty useful. When people started taking this process, there were major changes in what we saw. So if you thought that the sun, the Earth was the center of the universe, it was a pretty big mind shift to kind of go like, not so much. And so we were seeing like major revolutions in thought in science, which makes some people say like scientists are constantly, changing their mind about even like really big stuff. What you're seeing, though, as we're kind of going forward with this process, is yes, we're constantly changing our minds about stuff. You just look at COVID advice, right? At first you thought it was this, and they're like, no, actually, this is the way that it's more spread this way, then this is the recommendation. So recommendations will change based on that evidence. You should expect that. But what you are not going to expect is somebody to go like, you know what? It's actually the miasma, right? That the germ theory of disease. No, it's that we've been breathing the bad vapors and from the swamp, and that's what's causing COVID. So science is constantly changing things, and as you look at any area of theory, for instance, evolutionary biology, what you're seeing is there's a ton of debate in it, but sort of where that debate is getting increasingly refined and specific. It's not going to be like tomorrow somebody's going to wake up and kind of go like, what? Insects formed out of rocks, right? That's not where this level of change in discourse is going on. So we are able to sort of figure things out, and every once in a while there's something that just isn't on people's radar, and people are like, oh, like you go like you think you have gravitation figured out, and then you start to look at things at relativistic speeds and densities, and you kind of go like, oh, and then somebody else comes up and says like, here's an explanation for it. So the idea that what you're figuring out may be completely thrown out tomorrow, as we go forward in this process, becomes increasingly less likely. Still, you want to be constantly open to change, but the more evidence and data you have, the more you are able to the more useful your explanations and predictions become. So as Avea is pointing out, the sort of idea of truth versus useful. So we're going to constantly keep our scientific humility. We're going to sort of say like, this is my best understanding to date. We are not, and sort of revolutions in science, the more that we kind of explore this, what we're saying is like, quantum theory is a revolution in science, but is it changing our understanding of the orbits of the planets? No, it's not. But these, with this tool of science, we're getting more and more slowly towards a more accurate understanding of the cosmos that we live in. And again, that's one way of knowing among many. And but when we're putting on our science hats, that's the pool we get to play in, and it's beautiful, and it's a lot of fun. So I want to thank everybody for being with us today. These Nature Journal Educator forums, I think, are becoming where there is the most interesting kind of discussion in our community right now. And I really want to thank everybody here for your participation and involvement. If you are new to this, I want to let you know that you are welcome to participate, and you can do that through the chat. You can do it through just sort of anytime there's sort of a kind of a pause in discussions. We invite you to insert yourself into the discourse. And again, thank you all so much for being here today. Before we go out, does anybody have a thought or an idea that you were not able to share that you would like to do so now? All right. Well, my friends, be safe. I want to remind people in the United States, you're coming up towards this Thanksgiving holiday that we have. We are close to having vaccines, and it's going to happen. Just a little bit more time of sticking with this. This isolation is painful, and it is hard, but it is what we need to do right now to keep our to take care of our larger community. And as much as we would like to kind of get out and get together with family, the kindest things that we can do right now are to protect ourselves, to protect each other. And that means family time over Zoom, I agree, it's not the same thing. But let's just hold out a little bit longer and wait for the process of science right now to work on a cure for this thing. But along with those vaccinations, we also need to be really adhering to our social distancing, and we're all tired of it. And what I'm seeing sort of more and more is that people are kind of, you'll get together with just a few people, at the start everybody's wearing their masks, and then 30 minutes into the visit, the nose pops out, and then people are kind of taking them down because because we have personal bonds with each other, because we love each other, it feels like really goofy to be sitting there with this mask on. And so those barriers come down, and you wouldn't just walk right up to people and take the mask down, but it's the frog in the pot thing. These little kind of changes, we slowly get ourselves into situations where we end up not making the safest decision for ourselves. Know that that's just human nature, and we have to fight against it. And let's continue to take care of each other, take care of yourselves. As a community, we can do this. And as educators, we can do a lot as role models to encourage the people in our circles to get through this. So thank you all. Be safe. Happy Thanksgiving. And I will see you all again soon.
Thanks.
Thank you all.
Thanks,
Hi,
Jen.
everyone. Happy Thanksgiving.
Happy Thanksgiving.
Happy Thanksgiving,
Thanks, Jack.
everybody.
Thank you.
Thank you.
Happy Thanksgiving.
Thanksgiving.
Bye-bye.